Alright, today we are doing lesson 16, revisiting key features of graphs. Our objective is that you should be able to interpret the key features, including intercepts, increasing and decreasing intervals, and positive and negative intervals of graphs. So our reminder for intercepts. X-intercept is where the graph crosses your x-axis. Y-intercept is where it is crossing the y-axis. A relative minimum is the lowest point, like the bottom of a hill or a bottom of a valley. Relative maximum is the highest point, so top of a hill. Your increasing interval is where it is going up, where you're seeing a positive slope. The decreasing interval is where it is going down and you're seeing a negative slope. And then your positive interval is where it's over the y-axis, and negative interval is where it's below the y-axis. These three are x-intercepts. Down here, this is a y-intercept. This top of the hill is a maximum. Bottom of the valley, minimum. Alright, so we are practicing identifying these pieces and writing our intervals. Remembering, when it comes to intervals, we care about the x coordinates. The y is not really anything of great importance for us. We care mostly about the x. As always, start with negative infinity to the left, positive to the right. We're going to examine this graph, come up with our values to start. I'm crossing the x-axis at negative 2 here. I'd estimate my intercept or my minimum to be about negative 1.5. I have an intercept at negative 1 again. Looks like my maximum here for my y-intercept is at 4, the 0.04. Another x-intercept at 1. I would estimate this minimum to be about 1.5. Another x-intercept at 2. And back toward infinity. Using that less than x, less than notation. So start on the left side as I read the graph. Am I increasing or decreasing? See, I'm moving from negative infinity to negative 5 with that downward slope. So that is a decreasing. So I start at negative infinity, put the less than x less than, and I continue decreasing until negative 5. So at exactly negative 5, that is a turning point. So at exactly negative 1.5, that slope is 0. It's not increasing or decreasing at that one particular point. So when I switch directions now from negative 1.5 to that next turning point where x is 0 at the y-intercept, I am now increasing. So you notice we're not putting any equal signs on them because at this one exact point, the slope is in fact 0. It's not increasing or decreasing. So now I've changed directions again. Those are turning points, those maximums and minimums. I'm decreasing again. So from 0 to 1.5. And then I turn one more time and increase from 1.5 to infinity. The last part is my intercepts. I want those actual coordinates where I cross my x and y axis. Y-intercept is easy. Following it down, x is 0, y is 4. X-intercept, there's 1, 2, 3, 4 of them. Our x has a value, the y-axis shows me y is 0. So negative 2, 0. Negative 1, 0. 1, 0. And 2, 0. Great. So moving on. Again, we are finding where is it increasing and decreasing? What are the x and y intercepts? So I need to examine my graph. Left side goes toward negative infinity, right side toward infinity. I see a turning point. The x is -2 there. Estimating my x-intercept, about like -1.8, so maybe I'll go ahead and list them. Oh, I also see an x-intercept here. Let's see, no more x-intercepts. Another turning point. Looks like x is -1 when I follow it up. I have a y-intercept. I'll go ahead and write that down. And another turning point here. I'd say that's probably about a 0.5. Seems like a reasonable estimate. And I am ready to go. So starting on the left, I can see that I am increasing. So increasing from negative infinity to -2. I change direction, so now I'm decreasing to -1. Increasing again, right where I left off, until 0.5. And last. So this shouldn't be so bad because we have really taken some time on this before. It is just a review. The thing you have to remember is you care about x values when you're coming up with these numbers. And then the fact that at these particular exact turning points, it is actually a slope of 0. It is not increasing or decreasing. We're not using any equal to signs. One last one. So again, we're starting with labeling. Where's negative infinity, positive infinity? Negative infinity on the left, positive on the right. I need to find my intercepts. So I see 4 x-intercepts. I can list them. -2, so y is 0. I have 0. Y is 0. 1. Y is 0. And 4. Y is 0. Then my y-intercept. It crosses at the origin. That is also your y-intercept. Then I need to examine it. Find those turning points so that we can estimate it. I'm estimating a little crooked. Try again. A little bit over a -1, so maybe we'll say, well, like a -1.2. Maybe -1.2. And then this one looks to be about 0.5. And up here, so it looks to be about 3. So we are ready to go. Figuring out where do I start, where do I end? Is it increasing or decreasing? It is increasing. So starting at negative infinity, ending at -1.2. Then to my next spot, where do I start, where do I end? Start at -1.2, end at 0.5. Where do I start, where do I end? Start at 0.5, end at 3, and finally, where do I start, where do I end? Start at 3, end at infinity. As for your homework, same thing, practice. Mark where it's positive and negative infinity. Figure out your intercepts. Identify the values of x at those maximums or minimums. And write down your intervals. So you're doing number 1 and number 2. 3 is a review question. We just did it. You should be fine describing the transformations. For 4, you have an interval, a set of x values. You have to decide which one shows that it is always increasing during that time period. 5 shows you a table. The exponential function has the values in the table below rounded to the nearest hundredth. If the equation for this function was written in the form y equals a times b to the x, then which of the following is closest to the value of b? You can use L1 and L2. Remember, to get an exponential function, it's stat, calc, 0, exponential regression. And number 6, a sample of 10 large eggs were weighed, shown with the results below. You want to find the sample standard deviation. This is not the entire population. It's just a sample. It goes into L1. It's stat, calc, and then it's the one variable statistics. And you are looking for the one with this notation. Best of luck. See us if you need any help.